Start.
Hello, my dear friends. So today we will do the experiment digital to analog converter using R to twice R ladder. Okay, and 741 op amp. Okay, so here we need the registers for making the digital to analog converter and an op amp and a breadboard. Okay, so we have the register here. These are the 1 ohm register and these are the 2 ohm register. Okay, the resistors ratio should be R to twice R. That means if it is 2 ohm, 2 kilo ohm, say I will show you. Look at, if we measure in the multimeter, it will show 2 kilo ohm. Okay, 2.1 say, and we will take it is approximately 2 kilo ohm. Okay, and for this we need the 1 kilo ohm resistance and the 1 kilo ohm resistance. Okay, so we have to maintain this ratio 1 R to twice R. Okay, and here is the circuit diagram to make a digital to analog converter. Okay, this is the circuit diagram. Now with the help of the breadboard we will draw this circuit diagram in the breadboard using the op amp and the resistor. So let's connect the resistor and the op amp. Here we have the IC 741. Okay, so here these are the 2 ohm resistor and these are the 1 ohm. Okay, 1 kilo ohm. Say now I am putting this 1 kilo ohm resistance. Like we need the 3, so we need the 3 1 kilo ohm resistance. You can see here R. So I am putting this resistors. This is 1. Say, please check the connection properly. Now from here I am putting another like this and this one, 3 1 kilo ohm resistor. Okay, like this R, as shown in the diagram, R. This these are the 3 in the breadboard. These 3 are the 1 kilo ohm, 1 kilo ohm, 1 kilo resistor. Okay, now we need to now we connect the 2 kilo ohm resistor. Okay, here we need 1 2 3 4 5 and total 6. This is the feedback resistor. Here we also need a 2 kilo ohm feedback resistor. So let us put in the breadboard. Now from this register, as shown in the diagram, from this register we will put this 2 kilo ohm resistor like this. Okay, this is the 1 kilo 2 kilo ohm resistance. Similarly, put all the resistors. Check whether connections are proper or not. Okay, now I have put this 4 register 1 2 3 4 here as shown in the diagram, 1 2 3 4. So we need another 2 kilo ohm resistor. This one the another 2 kilo ohm resistor from here to the ground. As you see in the diagram, it is one resistor to the ground. So okay, this now I have connect this 5 2 kilo ohm resistor. Now we need the feedback resistor to the op amp. As you can see in the 471 op amp, here are the pin diagram for the 471 op amp. So first this is the offset voltage, this is the inverting input, this is the non-inverting, this is a plus minus VC, and this is a this is the N. Here no connection, and here the positive VCC and the output and the offset now. Okay, now we have to put this feedback resistor as you shown in the diagram. This is an inverting input. Okay, so inverting input and to the output. So in the IC 471, the terminal 2 is the here, second terminal is the inverting input. Okay, so here second terminal is that, this is the second terminal. Okay, 1 2, this is the second terminal. We will connect the second terminal to the output is the 6. So this is the 1 2 3 4 5 and 6, like this. Okay, now all the resistors are placed as shown in the diagram. Now we will make okay. now after done the all the connection of the resistors, now we will put the connecting wires. One is connecting wires from the inverting input to the resistor. So here the inverting input is this second one is the inverting input. So one connection is goes from this the second terminal from this. This second terminal to here. Okay, to the resistors here. Okay, now we will apply 12 volt DC. This is the plus VCC, plus minus VCC. So feedback. Now we will apply the plus to 12 volt and minus 12 volt in the terminal. In the terminal 4 and 7. So in the terminal 4 we apply the negative. This one is the negative. Okay, you saw in the, you can see the sign here, negative, and this is the positive, and this is the ground. Okay, this is ground, this is positive, and this is negative. So this is the negative terminal will connect in the terminal 4. So here 1 2 3 4 terminal. In this 4 terminal we connect the wire negative 12 volt. Okay, after connect the negative 12 volt, we connect the positive 12 volt to the terminal number 7. So the terminal number 7 is this. You can see in the IC, this is the 1 2 3 4. These are the first 4 terminal, and after this side 5 6 7. This is the 7 number terminal. Yes. Now, and finally we'll connect this to the ground. So we're making this as ground, so we connect this simply on the ground in the breadboard. Now after connect plus minus DC, we have to give in this circuit the digital input, say 0 and 1. So for the digital input we will use this. From here we will keep the inputs. So here the digital, so here the input is like the 5 volt act as a 1 and this is a ground is act as a 0. Okay, so here 5 and 0. So these are the 4 terminals we will put on the registers. These are the, as we are taking the 4-bit digital to analog circuit. Okay, 4-bit. So for the 4-bit we will put the these 4 wires. This is say 1 2 3 4. These are the 4 bits. Okay, this was the 4-bit terminal. We will connect this 4 say to the registers here 1 2 3 4, these 4 registers. Okay, as you can see in the diagram here, we will put one is one, second is here, third is here, and fourth is here. So we will give this 4 5 volt like this. Say we will connect this like here and here and here and here. Okay, and the negative terminal goes to the ground. So let's connect this in the breadboard. So here are the 4. So we'll connect ये वाला last वाला है ना. So here the 4 bits. Say first bit is like 1 1 1, or you can say see this is the 4-bit register. So first bit will connect to the first register here. This is the first bit connected to the first registers like this. Okay, make sure the connection should proper, otherwise you will not get the exact value. So here, and the second one is connected to the, will connect to the second register. This is so the second number of bit, this will connected to here the second registers. This is the second number of register and I'm connecting this simply. Okay, now third one is this. So this is the third one and I'm connecting this to the third number of the registers. This. Okay, finally the last one. The last registers we are connecting to the last register. This. Now our connection is almost finished. Now I have to connect this last one negative. These are all the positive values and this will be the low value. So for this we have to connect this to the ground here. I'm connecting this now as we know that this breadboard is separated from this breadboard is separated from this line, as you can see here. So we have to make this short. Okay, so that the connection should be all correct. So I am making this breadboard as short, so this all the circuit are connected now. Okay, now finally we will take the output voltage from here using a multimeter. So for this we can take the output voltage using the multimeter. The output voltage should be taken through multimeter and we have to connect this multimeter. This is the common term, so this common will goes to the ground. Okay, this goes to the ground here. This is now grounded, as you can see here. This is now grounded and the positive terminal is goes to the output of the op amp. Okay, so here in the IC in the pin number of the 6 is signify the output. Okay, so we connect this positive terminal of the multimeter to the 6th number terminal. So in this terminal we will connect this. Now our all connection has been finished over. Now we'll check the readings. Okay, let's see it will work or not. So simply turn on the switches. So I'm turning on this last 12 volts. We'll take the voltage. Okay, so we'll take the DC output voltage. So I'm turning on this 12 volt DC supply, and now I will give the values, the digital values from this. So in here you can see that this HI defines the high. High means you are applying the positive 5 volt, and LO defines the low. That means you are not applying any kind of signal. That means 0. This applies the 0, and this simplifies denote the high. High means 1. So let's the all the switches in the low, and we can see the multimeter. So sorry my dear friends, we have left one connections. This one we forgot to connect this terminal. This is the terminal number of the 3. That means the IC terminal number 3, non-inverting input. So non-inverting input should connected to the ground. Okay, so here the terminal number 3, that means this first, second and third number of terminal. This terminal should be connected to the ground. Okay, so let's connect it to the ground. Simply I am connecting this in the ground. Here I am connecting this terminal to the ground. दूसरा वाला मल्टीमीटर लेके आता. Okay, sorry my dear friend for the inconvenience, because this multimeter is showing the fluctuating value, so we will not taking this multimeter. So instead of we are taking this is not showing the some fluctuate value. Okay, so our connection is already done. Now these are the logical input. Say high, this is the in the low. Okay, this is also in the low, this is also in the low. That means all the digital inputs in low, and we will calculate the output voltage using the formula as shown in this here. So output values we will calculate it using this formula. V out equal to minus of RF by R. RF is our feedback resistance, R is our resistance as we given in this, and VR is the reference voltages. Here the reference voltage is 5. Okay, because we are taking the 5. Okay, 5 and 0. So reference voltage is 5. So these are the bits. Okay, this is the we take the 4 bits. Okay, we take the 4 bits inputs, digital inputs. So 1 2 3 4, these are the, this represents the bits. Okay, so for the 4 bits we are getting the total 60 different bits. Okay, as I mentioned in this copy. Okay, you can see the different bits, the 0 0 0 0 0 0 1. Now we will calculate the value. Okay, now you can also calculate this value using this formula by directly putting the value in this formula. Like the VRF is our is 2 kilo, R is 1 kilo, and VRF is the 5 volt. And if we take so here if you put the values of this B0, B1, B2, B3 like 0 0 0, and then you will get in the calculated value as 0 volt. Let us observe experimentally we will get or not. Okay, so this is our multimeter. Okay, I am turning on this switch now. This is these all switches are in the low. Okay, I am giving the low values, so you can observe in the multimeter this we will get exactly the 0. That means our all the connections are the proper. Okay, now for this you have to identify the least significant bit and the most significant bit. Okay, you know that in the digital signal, this is the first value is called the most significant bit, and the last value is called the least significant bit. That is, if this is the, I say, if this is the say 4-bit digital input, and here this is the MSB, this represents the MSB and this represents the LSB. Then from here, how we can check this 4 digital input, which one is the LSB or MSB? Okay, for this you can easily check using the multimeter. Now let's turn on this last, say this D number of the switch. Okay, if I am turning it high, then it shows some values in the multimeter. Say this is the 0.6 or 7. Okay, so this shows a 0.6. Now I am turning off this, and I will turn off the last one. This is the A. Okay, so if I am turning on this, I am giving the high, then we get the high value. That means this is the most significant bit. That means this is the most significant bit and this is the least significant bit. So in our representations like B0, B1, B2, B3, so B0 is what? B0, the B0 value is this one. This one's the B0 value. Okay, that means this is the B0, this is the B1, this is the B2, and this is the B3. Okay, we have identified the B0, B1, B2, and B3. So here D is the B0, C is the B1, B is the B2, and A is the B3 in our representation as we take in the formula. Now let us take the next one value. Say we will put the B0 as high. Okay, and let's observe the how much it will be. Now all the values in the low. Okay, so we'll getting the 0 here. In the multimeter we are getting 0. Now I am making this B0 simply high. Okay, I am making it high. So that means if B0 is high, that means the 001 and all others are the low. Okay, here you can see this you can see this is the in off, that means low, low, low. That means 0001. Okay, for this code we will getting the value 0.6. So we will note down here. So for this I am getting 0. For this 001 value we will getting 0.66. Okay, and you can also calculate this value using this formula by putting the value of B0 in here, and all other rest of the 0 you can also simply calculate using this formula, and you can check the difference. Okay, the observed value and the calculated value. Okay, now I will show by calculating this value. So here RF is the 2 and R is 1 and PRF is 5, and here the B3 is 0 by 2, and this is the 0 by 4 and 0 by 8 plus 1 by 16. Okay, now we will put this value in the calculator. Please give me calculator. So here we will getting 10 into 1 by 16. Okay, now 1 by 16 means 1 divided by 1 6. It is 10 into 0.625. Okay, so if 0.6, okay, this is the 1 by 16 means 0.0625. so if multiplied by the 10, then you will get 0.625. so this is the calculated value for the B0 is 1. So this is the calculated value. So we are getting this is 0.625, and in our experimental value we are getting 0.62. so it is nearly equal. You can see the difference. Okay, and all the rest values you can calculate using this same kind of the method. So we will show how to calculate. Okay, thanks. You can check for all the values. Okay, bye bye, thank you.